All right, well, it's 8 o'clock, so I suppose we can get to it. Um, all right, so last time we talked about conditional expressions, and we'll still kind of need a little bit of that for today's stuff. Um, so let's go back to our eggs example, right? What was it that when it came to the cracking of the eggs, did we have to do? We cracked them, but we said, well, cracking one egg is really the same procedure as cracking multiple eggs. So let's just say repeat the procedure 12 times of crack eggs. Okay. Um, and so anytime you have something that you want to repeat, um, however many times, a specific number like 12 or just basically indefinitely, um, then you're using an iterative expression. Oops. Okay, um, so let's start looking at how these would be expressed. So there are basically three kind of categories of iterative expressions: a for loop, a while loop, and a do while loop. And not all languages have all three of these. Um, most languages have just the first two. And we'll talk about what the difference is between the second and the third um, in a minute. Okay, so the for loop is you want to use a for loop basically anytime you're repeating a procedure a, a predetermined number of times. Okay, so for example, our egg cracking um, routine, right? We said 12 eggs. We want to crack 12 eggs, so we're going to repeat the crack egg procedure 12 times. Okay, so if I were to write this in English, then I could say something like this, something like that. Okay, it gets the idea across to you that you're going to do the crack egg routine a specific number of times. Okay, how would this look in various programming languages? Okay, so let me say here, this is example one in English, and example one in, say, Python might look like this. Um, let me think about this. Um, okay, say something like this. Okay, now Python I think is somewhat annoying because so how many eggs are we going to crack here? 12, right? So what should I call egg number one or the first egg? Should I call it egg number zero or egg number one? Well, it's kind of up to you, right? So often we start counting with zero. If I do, then what are the numbers of my eggs? I've got egg zero all the way up through egg number 11. Okay. Now, one thing so in Python, what I'm going to do is I'm going to define a counting variable here, in this case, lowercase I. Okay. And lowercase I is going to basically keep track of which egg I'm on, or equivalently, how many times I've gone through and done the procedure, okay, of cracking egg. And now, what are the range of values that I can take on? Well, what do you think it could take on? Just looking at what I typed. Zero through, okay, that would be a natural thought, right? Zero through 12. It's actually zero through 11 because, okay, so for whatever reason, the guy who came up with Python 12 is not included, but 0 is. And I want to fly to wherever he lives and punch him in the face, okay, for doing that. I don't know why he made that decision, but he did. Okay, uh, so what that means though is if I know that I want to go eggs 0 through 11, then that means my range statement goes 0 through 12. Okay, so 12 is sort of the the first number that's not included. And again, I don't know why he did that, but he did. Okay. Um, and so, I mean, is that irritating? Does that make sense? Not really. Deal with it. Okay. Okay. So that would be what this sort of procedure. Excuse me. I'm about to sneeze. Sneeze averted, maybe. No. Hey. Sneeze averted. That's rare. Um, Managed to avoid it. Okay, anyway, so that's what this might look like if you were to write it in a Python looking language. Um, and if we were to write this in, say, C or Java, it might look like this. Okay, so um, so let's sort of look at what's in common and what's different. So the first thing is that's common is in both versions, I want a variable, okay, some object to keep track of which egg I'm on, or equivalently in this case, which repetition I'm on, okay? And I don't have to call this a letter I, but that's certainly a good choice. Um, and so I have to define what's the starting value of I. Well, in this case, what makes sense? How about 0? Because we're going to start with egg number 0. And then I have to define how far am I going to go? Am I going to go up to egg number 11? So under what condition do I stop? When I hit 11, okay? So here I put I less than 12. I could have put I less than or equal to 11. Okay, that would have worked. Um, but I just went ahead and I picked I less than 12. Okay, now the next thing, this I++ statement, is something that isn't in Python because it's sort of assumed to some extent. And the idea here is, what do I do to the number I after I finish cracking an egg? Okay, so the first value of I is 0. What's the next value? Okay, how did you get from 0 to 1? Well, yeah, but what did you do? You added 1, okay? And so did I have to add 1? Well, in this example, yes, but in general, not necessarily. And so I++ is sort of shorthand for saying I plus 1. Now you might ask, how is typing plus plus any shorter than typing plus 1, but it's useful. Um, okay, so in this particular example, each time I'm going to go from one value of I to the next value by just adding 1. One could imagine that I would skip by 5s, for example, for some squirrely reason. Like I wanted to crack every 5th egg or something like that. I could do that if I wanted to. Okay. Um, all right. So let's see, questions, preguntas, fragens here. Yes. Right. Okay. And see, there though, there I would only end up cracking 2 eggs, and or sorry, 3 eggs. Let's think about why. if the starting value is 0 and I add by 5s each time, then I'm going to crack egg number 0, then egg number 5, and then egg number 10, and then 15 is bigger than 12, so I'd quit. Okay. Yeah. So I'm not sure why I want to crack every 5th egg, but hey, we could do it if we wanted to. Okay. So does that kind of make sense? So same example, basically. And then let's also go over to, and I'm going to have to go over here. All right, so Chrome. Transform, fit to screen. Okay. All right, so let's go over to Chrome and let's look at what this would look like in Scratch. Okay, so in Scratch, I could have something like this. Okay, so let's say 12 times. Okay, so here the counting variable I, or which is what I called I in the previous 2 examples, is sort of hidden from you, so you can't get to that number. We'd have to kind of go through a contrivance to do it. The other thing is that all you do is specify how many times you want the process to run, not the actual values that you're doing it for. But again, that makes it, this is easy for kids, right? Because it's impossible to mess up. Okay, if I wanted to do something a little bit more like what I did in Python, where I was keeping track of exactly which egg I was dealing with, then I would have to do something like, let me make a variable, I'll call it I. I would have to do something like set the value I to 0, then I would have to repeat 12 times. I'd have to crack egg number I, and then under variables, I'd need to change, oops, something like that. Okay, so here, the value of I would start at, say, 0, and then I would crack egg number I, starting with egg number 0, and then after I do that, I just add 1 to the number of eggs, okay? Or add 1 to the counter, not to the number of eggs. Okay, make sense? Yeah. So it's a little bit contrived, and when we get into this a little bit later, we'll talk about why in Scratch this is annoying, the way that we had to do that, but we'll get there. Basically, this has to do with those of you who have seen a little bit of programming before, the idea of scope. Okay, so global versus local scope is kind of an issue, but we'll talk about that more later. All right. Anyway, so let's go back over to Adam here. Okay, so these were all examples of the for loop construct. Okay, and let's just actually code up a function example or actual working example. Okay, so let me make a new function here, and I'm going to, let me save it real quick. So let me make this okay, so I'll do I think that's what we want, and then let me pull open a console here. Oops. Okay, so there. So, and you guys online can't see this, so hang on one second. Let me put that here, this there, and then let me do full screen. There. Okay, so you should see on, make sure this is coming through on the stream correctly. You should see on the left of your screen after the the Twitchception. You should see on the left we've got our Python code, and on the right I've got the terminal where I'm executing it, and the stream is dying on my laptop here. Is it showing up okay? Does anybody have the stream open? Yeah, okay. We'll type in the chat. Let me make sure that that it's looking okay. All right, so so what did I do here in my code? I just said for I in range 0 to 12, and then I can't, you know, the function, there is no function that I've defined to actually crack the egg. So instead, I'll just print the instruction, crack egg number, whatever. Okay, so for example's sake, that's fine. And so then when I execute this, then look what I've got: crack egg number, and then the value of I is also getting printed, and there it is. So crack egg numbers 0 through 11, and Gucci. Okay. All right. So questions, questions, preguntas, and or fragens. Okay. Yeah. Good, Koi. Yes, it's finally showing back up for me too. All right. So does that kind of make sense? Yeah. All right. So that's a an example of a for loop. All right. So let me go back over to Chrome, and let's uh, let's look back at here at Scratch. Um, for the uh, two other constructs. So some languages, Scratch, for example, has a forever repeat loop, okay, which would basically never terminate unless you explicitly add in a termination command. Um, Now, it might seem kind of silly to have a loop that keeps going forever. Um, and to some extent, maybe, you know, you can see why that would be the case. Where that would be useful would be like, let's say, for example, you're programming a game. Well, your game should run basically forever, right? Until you explicitly hit the exit button or whatever. So you could put your entire game in sort of a forever loop. Um, we'll, but most languages don't have an explicit loop that's to do something forever. You can build it out of a while loop. Okay, so let me get rid of him. And um, let me actually go back over to here, and let me make a new file. And let's see, we'll go back to full screen. We'll call this one, oops, that's not where I wanted to put it, but that's okay. All right, so we'll make a while loop. Okay, so here I could say something like, well, let's see, what do I want to do here? Here, let me just say this for now. Okay, so here I could do something like, say that there's 12 eggs, and say, but I could say there's 200 eggs, or whatever, right? While I have eggs, crack them, okay? And so how many times is this loop here going to run? How many times would this run? Yeah. Until num eggs is 0, okay? And so how many times is that if num eggs starts at 12? 12 times, okay? Because it'll run for when it's 12, 11, 10, and so on down to 1, and then when it hits 0, it won't run anymore, okay? But, so this is why, so notice the way that Cole answered me. He didn't say 12, okay? Even though in this particular example, it would be 12. Now, why is not saying 12 a better answer here? So just concentrating on the stuff that's highlighted. Is anything in the highlighted statement assume how many times it's going to be repeated? Not in the highlighted part. Okay, so in this case, the number of times that the thing might run is going to be dependent on the value of the variable num eggs. If I changed the number of eggs to 200, would I have to change anything about the loop? Wouldn't have to change one thing at all, okay? Whereas if with the for loop construct, if I change the number of eggs to 200, I would have to rewrite part of the loop, okay? Yeah, question. Yes. Okay, so the question was, does an if then or a conditional expression, those only get executed once, and if you want them to get executed more than one time, you have to put them inside a looping structure. Yeah, okay. Okay, so if I would run this, so let me save it and let me get my console back open. And I put this in the wrong folder, so. Okay, and then let's just count to make sure that we actually have the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it did run 12 times. Okay, so does that kind of make sense? Now, what would happen if I deleted this line right here where I said num eggs equals num eggs minus 1? It would go forever, okay, because what's the value of num eggs when I start this whole contraption? 12, okay? And if I don't specify something to do to modify the value of num eggs, it would stay as 12, and each time I hit the loop, I would say, is the number of eggs bigger than 0? Yep, it's 12. And it would stay 12 forever. Okay, so this would run forever. Um, that, by the way, answers the questions of how do you do an infinite loop, because let's sort of look at structurally what we have here. What's in the parentheses here for the while loop? Okay, in this particular case, it's num eggs bigger than 0. Okay, great. But let's think about like what kind of data that is, or what kind of object that is. Okay, so think about what the language we were using towards the end on Friday. What kind of thing is that? Is Urangi for the clutch, for the 360 no scope? Huh? Oh, so what kind of data object is in the parentheses here? In this case, it's numeg bigger than 0, but what kind of thing has to go there in the parentheses? Okay, something that evaluates to a Boolean, okay, meaning it's a logical statement that can either be true or false. That's it, right? So in this case, the value of num eggs is either bigger than 0 or it isn't. There are no other options. Okay, so no matter what I put there, it's got to be something that evaluates to either true or false. Okay, does that make sense? So this actually kind of answers the question, how can I make something run forever? Well, I could do this. While true, well, that's always true, right? Or I could say something like, while 1 is bigger than 0, that's always true. Okay, but in Python, actually, one thing that's nice is that you can just do this. Okay, so if I run this, what's going to happen? Oh, is it capital? It's capital T. Okay, so it's a little hard to see here because this is just running forever and ever, and it keeps printing, and I have to, kill the process to do that. Okay, so this printed. Well, look at the little slider bar here, right over on the right. It printed a gargantuan number of times. Okay. All right. Anyway, so I could do something like that where I have a forever loop if I wanted, and that's one way to do it. Okay. Now let's contrast this with Scratch. So let me go back over to Chrome, and I want. What the? It's a good thing I put the Ethernet switch in here because the Wi-Fi in this particular spot is horrible. Okay, so let's contrast this with the while loop constructions that are available in Scratch. In Scratch, you have this, repeat until. Okay, now this is sort of backwards in a sense from the while loop that's in Python. In Python, what did I specify? I specified the condition to continue looping, okay, not the condition to stop looping. Scratch has it the opposite, okay, where I specify when do I stop looping. Okay, so in Python, where I coded this, I said while numEggs is bigger than 0. Here, I would say repeat until numEggs is equal to 0 or less than or equal to 0, either one. Okay, slightly different, logic, but we can turn anything you can write in one terms, you can write in the other. But in particular, like what we were talking about a minute ago with what goes in the parentheses, what type of object has to go into the little socket there? What kind of socket do we have? Okay, so it's a diamond D socket in Scratch is what kind of data object? What was it, the parenthesis thing in Python? It had to be something that was either true or false. Okay, so a Boolean. And the diamond dudes in Scratch, same thing. They evaluate either to true or false. Okay. So whatever condition we would write would have to be a true false only type object, and that would get slotted in right there. Okay. Is that Gucci? Yes? Question or no? No? Okay. All right. So slightly different logic there. But hey, that's what we got. All right. So let's go back over to my Windows here. And let me go back to my sort of list. So we've talked through now the for loop and the while loop. Okay, some languages have a third category, which is called a do while loop. And the difference between it and a while loop is a little subtle. So let me let's look at the while loop that I had, which was this one. Okay. So the way the while loop works is I first check the condition to determine whether or not I'm going to do the procedure that's inside. Okay, so right now, let's say numegs is 12, and then I hit line number 2 while numegs is bigger than 0. And I say, well, yes, 12 is in fact bigger than 0, and then I do the loop body, and then in this case would repeat that 12 times. But when did I check the condition? Before I did anything or after I did stuff? I did it before, right? So I checked, do I continue looping or do I do the stuff that's inside the loop body? Um, and I made that check before I did anything. Okay. A do while loop does the check at the end rather than at the beginning. So what that means is that a do while loop is guaranteed to run at least once. A while loop is not guaranteed to run at all. It depends on the condition. Okay. Um, now, there is no construct for this in Python, so it's a little hard to kind of uh, show you what it would look like. But if I wanted to have something, let me make a new file here. If I wanted something to run exactly before I checked whether or not to continue doing it, then I'd have to do something like I'd have to do something like this. So let me save this as and put it in the correct directory this time. I'd have to do something like that. Okay, so if I wanted to do something in Python that was kind of like a do while loop where it executed something once and then checked whether or not to continue, I'd have to do it like this. I'd have to say, do the thing once and then repeat it however many times. So yeah, the do while loop, I think basic has that, although basic is kind of funny for a number of reasons. How many of you guys have ever programmed in basic? None of you? Seriously? Wow. Um, well, okay. How many of you guys had TI graphing calculators when you were in? You never programmed on those things? Huh? Yes? Guess what language you did? No? You did? What language were you programming in? It's TI Basic. Okay, you were programming in the language called Basic. Specifically TI's little calculator variant of it. Um, yeah, so anybody else, like, you had your graphing calculator and you programmed a quadratic formula thing for yourself so that you just type in the coefficients and bam, it would spit out the roots? No, nobody ever did that? Or stupid little games? Did you guys have games on your calculators? Yeah. Well, huh? Flappy Bird? Yeah. Well, I think actually at one point I wrote a program that made it look like I cleared the memory, but didn't actually. Like it just displayed mem cleared on the screen like it would if you actually cleared the memory. Yeah. So take that, Mrs. Gurley. Um, yeah, like before exams, we had to go around and she'd check to make sure that everybody cleared their memory. Right. Huh? Yeah. Well, I mean, not that I needed to. I just was like, I wonder if I could fool her. Right. So, um, yeah. Yeah, my eighth grade algebra teacher, her name was Tammy Gurley, Gurley. Now here's the hilarious part. Guess what her maiden name was? Manly Way. Manly Gurley. Mrs. Guy. Can't imagine what kind of jokes you told about Mrs. Guy. Um, yeah. So okay. Um, yeah. So the TI Basic. So I was like, why am I talking about Mrs. Gurley? Oh, right, TI Basic. Um, the language that you would program in on your calculator was basically, pun intended, a version of BASIC. And if you're not familiar with this, let me actually. Um, this is what I'm talking about. Okay, beginners all-purpose symbolic instruction code, but BASIC for short. Um, and anyway, well, actually, this is kind of a nice example. That's what a program to do a for loop in BASIC would look like. Right? Hola, Wikipedia. Anyway, so yeah, so not all languages are going to have these things, all of these things, but in particular, pretty much any language that you look at is definitely going to have the first two or some slight variation on them. Um, okay, so questions, preguntas, and/or fragans. This isn't too horrible, hopefully. Um, yeah. So now we can start mixing these things, and in a sense, right, every loop is also sort of got built into it a conditional expression. So, for example, if we go back to our while loop thing here, right? So it looks like I just wrote while blah blah blah, okay, but really under the hood, when this is executing, there's a conditional there, and it's the conditional is if num eggs is bigger than 0, then print otherwise move on, okay? And but it's sort of hidden, if you will, inside the syntax here for the while loop. Um, so this is why we talked about the conditional stuff on Friday first, and then are talking about the looping structures here because they all basically have a uh, they all have conditional sort of built in. Okay, the for loop, same thing. It's just saying, all right, have I hit 12 yet, or the max number, whatever it is. Okay, all right. So I think that's probably good for the iterative expressions. Any questions, preguntas and/or fragens? So one last little thing that some languages have, and so let me actually go to back to Scratch for this, is they have a stop or a break command that allows you to um, stop a loop mid loop, basically. Um, and in um, it, you have to be careful when you use these, but um, particularly in Scratch, because the stop can be like stop all. Like, let's say you did that. What do you think that stops? Everything, the entire program, every last little drop of code. So if you put one of those in there accidentally, and all of a sudden your program just stops, well, you know, good luck finding it in a particularly complicated program. Um, in Python or C, then you have a statement called break. Um, and so here would be just sort of a quick example there. Um, so what break would do is it would terminate the loop's execution when if you hit a break command, but then it would move on to whatever was right after the loop. Okay, you can't do that in Scratch. There is no break command. There's only the stop this script, but that terminates the entire uh, that entire like. So script in Scratch is anything that's like connected together. All of that stuff is one script, um, and we'll talk a lot more about that. Okay, so um, yeah, so C, Java, those guys have break statements, and if you have a nested loop, right? So like, let's say for example, I wanted to do some image processing. So let's say I've got an image up on the screen, then I actually would need a nested two nested loops. Okay, one to go horizontally and cover an entire row of pixels, and then the next to cover each of the rows, right? And if I have nested statements, then break, it only breaks the innermost thing that you're in, and then kicks you back out to the big thing. Um, anyway, all right. Well, I guess we can quit a little early, unless there are any questions, preguntas, and/or fragens. So, all right. So that was iterative expressions, and on Wednesday, definitely get some plenty of sleep before you get here because I'm going to blow your minds. We're going to talk about recursion, uh, and it will give you a headache. So come prepared. All right. See you guys on Wednesday.